Okay, so back to the computer, we have modified our function. We said we want to do the continued fraction for the square root of 3 here to do a comparison, and then we're going to evaluate 2 times f of minus 1. And we haven't done it yet, so we actually don't know what we're going to even see here. So, you ready?
Yeah.
All right, let's do it.
So let's see, we get 3/4 as our approximation for the square root of 3. And then for the convergence, we get 3 terms, we get 5/3.
Something doesn't seem right about that. I don't think we evaluated this function first.
Okay.
Because we got plus an x over 8 minus x squared over 128, so I don't think we're going to get 3/4.
So we get
there we go.
111 over 64.
Okay, 111 over 64 using 3 terms. And then 3 terms of the continued fraction, the third term is 5/3.
Okay.
Now, I don't think we can do the math for 111 over 64 in our head, but we certainly could see 5/3. Does that look like a decent approximation to the square root of 3?
I think the square root of 3 is around 1.7, and 5/3 is 1.66666.
Okay, yeah, that's
So-
good. Or you could square it, and it's 25 over 9.
Which is reasonably close.
Okay, so why don't we evaluate numerically?
So let's see.
5/3. Certainly a much simpler fraction than 111 over 64.
Yes. And
So
then
we're
square root of
and
3.
then scroll up so it's around the screen. All right, well, let's see.
Let's see. So this was our. This is the square root of 3.
Uh-huh.
And then looks like actually 111 over 64 is better.
Oh, okay. Well, that's neat. So it's the third term. Now, interestingly, if we scroll back up to the continued fraction, maybe we should look at the but the first 2 terms were integers, so maybe that wasn't so good. So maybe we should compare it to 7/4. Or
Yeah, maybe.
19/11. We can do both. But
So
do
let's-
7/4 first.
7/4, that's 1.75, so it should be.
Oh, yeah. I guess we don't need we don't need to do that. So what was the next one? 11/8?
19 over 11.
19 over 11. Yeah. So I remember. All right, compared to 19 over 11, which is also a much simpler fraction than 111 over 64 for sure. Maybe
Right.
it's.
So this is our square root of 3.
Yeah, actually. Huh.
Looks like this is still closer, actually.
Yeah. That's interesting. So maybe this time with 3 terms, even though we got a very complicated fraction, we actually did seem to beat it. What's the next one? It looks like the numerator or denominator is 15, so 26.
26/15.
So let's see if we can find the first one that beats it.
15, 26 over 15. 1.733333. Looks like this does beat it.
Yeah, it is a little closer. 1.732,
Barely close.
1.734, 1.733. Okay, so the continued fractions give us sort of the best approximations. So we expect to be able to beat this eventually, but we did have to go out. That's what, the 6th term? 1, 2, yeah.
Yeah,
Or,
6th
yeah, the 6th term.
term compared to 3 terms.
So the 6th term is still a much more simple fraction, 26/15. But the 3 terms of our series, 111 over 64, actually, about the same, a little better. We had to go out a lot more.
All right.
So this is both methods are actually really nice methods for approximating functions or numbers. And we'll study a little bit more tomorrow about how we can use this for other functions. Like maybe we'll do cube root or something like that. Cube root of 1 plus x.
All right.
All right, good job today, huh?